Was this like serious? Whatever. Okay. All right, so like I said, we do not have a ton of new material for you today. The only big difference from yesterday, we do have to do some more factoring on the problems than we did yesterday. That's the end of the world. And we're going to specify a little bit more. We're going to talk about when the zeros touch the x-axis versus cross. You saw that yesterday when we had those repeated answers. Well, today we're going to have maybe a few more answers and just a little more craziness, but overall the same general ideas as yesterday. I really don't have a lot of new stuff for you today. So if a zero/factor is repeated, we call that the multiplicity. For example, you can see all of that. We did the graphs yesterday. So like here when you have this x minus 3 cubed, we say we have a multiplicity of 3. There's 3 of those factors, okay? Now, we looked at this yesterday. Yesterday we saw we just had maybe a repeated answer, a pair of answers. Today we might get even a little crazier than that. So if you have an even amount, so yesterday you saw the pairs. You might see 4 of the same answer. You might see 6 of the same answer. Anytime you have an even amount, that touches the x-axis. So that's going to help me to draw these graphs, of course. If you had an odd amount of zeros, maybe you just have a single 5, or maybe you have 3 7s. Anytime you have an odd amount, it crosses the x-axis at that 0. So I'm going to use all those skills from yesterday. I'm going to think about the degree. I'm going to think about the ends. I'm going to get the zeros. I might have to factor a little more today, whatever. And then I'm going to think about the multiplicities. Are we touching the x-axis, crossing the x-axis, all of that good stuff. So start you off kind of easy. I gave you one that's still in factored form here today. Just a few more zeros, of course. So we're going to sketch the graph. We're going to try to sketch by hand. Of course, you could check on your calculator, but we're going to do it by hand today. We're going to talk about end behavior. We're going to get the zeros. We're going to plot some points. We're going to draw the curves. We're going to do all this stuff. So let's start with the end behavior. So I'm going to do my left end first, and we'll do the right. I always work left to right. So x approaches negative infinity. Bless you. Okay, then we'll get into the y's. Now, as always, I'm not going to get crazy and actually FOIL out that original problem. I don't have the space, we don't have the time. But I do want to know, of course, what would be the highest exponent we would have? What would be the degree of the polynomial? Well, we have 4 x's, 3 more here, so now I'm at 7, 8, 9. Because, of course, whether it's odd degree or even degree affects the ends. Now, I don't actually care what number it is, but I care what is the lead coefficient. Would it be a positive or a negative if we FOILed it all out, which we're not? What would be your sign on your lead coefficient? Positive or negative? Positive. I'm just going to put a positive symbol for dramatic emphasis. So, of course, your odd degree, the ends are split. One rises, one falls. And just like positive slope, I think about a positive slope. Left end falls, so y approaches negative infinity. Right end rises, so positive. Okay, so that's going to help me. Then it also, of course, wants us to get the zeros. Now, you'll see I've left all sorts of fun little blanks for you on your homework to fill all this stuff in. There will be a blank that says all zeros. So I want all 9, 9th power, 9th degree, even though they're repeated and it's obnoxious, I'm going to list all 9. Then I'm going to separate out which ones would cross my x-axis versus which ones would touch. So all 9. Oh, Lord. Okay. Well, if you set x to the 4th to 0, that's fun. What? You're going to have 4 answers. What are they? They're all the same. It's all going to be what? 0. 0 to the 4th. So I'm going to list 4 zeros, which I know it's obnoxious. I know. Okay, x minus 2 cubed. Of course, if we solve that, you'd add 2, you'd get 2, but you have 3 of them. How many negative 1s do you have? How many negative 1s? 2. So I'm like, holy cow, do I have all 9 answers? I know that looks gross. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay, yeah, do, okay. And like I said, you will see, like on a quiz or test, I have all these little blanks for you to just fill them in. It will ask you to identify zeros that touch versus which ones are going to cross. I'm getting carried away here. So remember, an even amount of answers, an even multiplicity, you touch. So I'm like, ooh, 4 zeros, even, 4 of them. I'm putting 0 down in the touch. 2, there's 3 of them. An odd amount, so that will cross. -1 is a pair, an even amount will touch there. So that's going to help me when I draw all the graphs. Okay, so let's put our points on our x-axis. So we have a answer at 0, -1, and 2. So we start with those guys. Put your points on your x-axis. Now I'm going to look at my end behavior, and I always work left to right. Left end falls. So my left end's down here somewhere. Here's my little arrow coming to it. I'm going to draw up to my first 0. -1 is on the touch list, so I am not going to cross through. Here we go. I'm just going to loop back around, touch it to the next one. 0 is also on the touch list, so I'm not breaking through. I'm going to loop. Oh man, my loop got carried away. 2 is across, break through, right end rises. So just need some sketches again today. So really nothing new, just putting it all together. Let me give you a second to finish drawing your lovely graph. Maybe draw better than I do, I hope. That one was crazy with our 9 answers on it. All right, now, not factored for, so we got to do a little bit of work. That's okay. First question for you, how many total zeros are there? 5. Okay, fun. So I want to get all 5 zeros. I want to think about the end behavior. I'm going to see what crosses and touches. We're going to do all the good stuff. So let's start. I see 4 terms. I would probably start by just factoring this by grouping. Let's split it in the middle. So we did a couple factor in the notes yesterday, not so much on the homework. You'll see more factoring today. So let's split it. I'm going to take out x cubed out of the front. So I'll need x squared minus 4. I'm going to take an 8 out of the back. X squared minus 4. Looking good, looking good. So since we, of course, have our matching x squared minus 4s, our factoring is working out for us. That's one of our factors. And then, of course, the other factor is what you use for your greatest common factors, the x cubed and the 8. Now, some of you might be able to right now, without doing any more factoring, get your 2 solutions off of here. Some of you can probably just solve that in your head. You know, I like to write it out, x plus 2, x minus 2. And we'll talk about this x cubed plus 8 here in a minute. Okay. Now, 5 total answers. Are you ready? First question. Give me these first 2 easy ones. -2 and 2, right? Now, let's talk about this guy. This is a throwback to first chapter, when we did all that crazy factoring. That is a sum, addition, of perfect cubes. So I'm thinking, oh gosh, I got to factor that down again from first chapter. So just a little side note, 2 cubed is 8. I know you know that. I just wanted to throw it up there so it's in front of us. So if I were to factor this, first we just take off the cube, so x plus 2. Your next factor would be you square the first term, change the sign from plus to minus, multiply 2 and x, and then you square the 2. Ooh, so much factoring. Okay, so you can see we're going to get another answer here. I'm going to get -2 off of this. So I've got 3, 4, 5 are coming out of this. But, I'm going to save you some work. Question, first question. Does this trinomial factor? Are there 2 numbers that multiply to 4 and add a -2? Sure isn't, sure isn't. So I'm like, oh my gosh, now I got to use completing the square or quadratic formula. And I'm like, wait, no, I don't. Because the 2 answers that would come out of this are imaginary. They're always imaginary when you factor with cubes. That second round is usually always imaginary. Just don't write this because you're going to run out of room. But if I went through and I solved this by completing the square, I'm going to move the 4 to the other side. Half of 2, 1 squared 1. Yeah, you're going to have -3 over here. So when I square root it, I'm going to have an imaginary. Clearly, I can't graph imaginaries, but there are technically 2 answers out of that. They just both happen to be imaginaries, so I'm not going to worry about them. So there are 5 total answers, but only 3 are real. 2 are imaginary. I'm going to run out of room. So let's do the end behavior, because it asked for that. We're going to do our left and right. I'm going to try to sneak it on. So again, degree is 5. So one end rises, one end falls. I always start with my x approaches -infinity on the left. X approaches positive infinity for the right. Now I'm thinking about the ends. fifth degree, so odd, one of each, positive x to the fifth. So just like positive slope, left falls, right rises. So y approaches negative infinity, y approaches positive. Now, because I'm running out of room, let's just try to get this graph drawn. And think about, at least I don't have 9 zeros written out. I'm just looking at these 3. I do have a pair here, so I'm just going to be conscientious. I have an even amount of -2, so I'm going to touch the x-axis at -2, and I'm going to cross at +2. I'm just running out of room. I'm running out of room. -2 and 2. Okay. Left end falls, so starting down here, remember -2 was our even amount, so we touch at -2, loop it through, cross at +2. Right end rises. I was just running out of room. So just for the sake of drama, I'm going to flip at those, give you 2 imaginary answers. Got it. Okay. All right. Any questions on that? Okay, last thing we've got. This is pretty easy stuff because we have talked about relative min, relative max. We've talked about all of that. Sometimes, again, I like to mix up the words and the vocab on you just so you're prepared for anything and everything. Sometimes they call it a local min, all right, local max. It all means the same thing. Relative min, relative max, local min, the same thing, okay? So, of course, you're ignoring the end behaviors, you're looking through the curves. Yes, your graphing calculators still find it. Second trace, you know how to do it. Here is something, one little tidbit of information that's pretty exciting. Maybe not. Okay. Local extrema polynomials. So if you have your polynomial, here's that degree n. We always are zeroed in on that degree on it. Polynomial degree n, then the graph has at most n-1 local extrema. So if you have a fifth degree, 5 minus 1, 4. You have at most 4 local extrema, 4 relative mins, 4 relative max, or a mixture of them, 2 of each, whatever, some sort of combination. So that's a quick, easy way to kind of have an idea of how many mins, how many maxes you should be getting. So, I don't even know why we're doing 3 of these, it seems like too easy. Determine how many local extrema the following polynomial functions have, then verify with the graph on your calculator. I'm not going to verify them all. We'll verify one. We'll do one. Just for our due diligence. So I'm looking at the degree. Highest degree, of course, 4. 4 minus 1, 3. So I'm going to say at most 3. Same thing with 5. 5 minus 1, 4. There's at most 4. And 4. 4 minus 1, 3. I don't really know why we're doing 3 examples of those. Probably could have done it. Okay, but let's just look at the graph to verify. Now notice at most, it's from a previous thing, at most it says at most, so it doesn't mean you necessarily have to have 3. I'm just going to put that first graph in and let's take a look at it. And I just want to review where to find max and min, of course, on your calculator. Plus x cubed, just see how select text, here we go, minus 16x squared, minus 4x, plus 48. And you know, I hate typing on this thing, so I always do a little scan to make sure I don't have a typo. I know, look at that. My window's off from whatever. I'm just going to hit zoom 6. We'll take a look. Now, of course, like, we should zoom out on this because clearly I can't see everything. I'm just going to do a quick zoom out before I get crazy about the window and see if that's enough for me. Oh boy, yeah, okay. So you can kind of see it there, kind of all shrunk it up together. You can see like local min, local max up there. Again, there's 3 of them. That's the maximum amount you can have. You find them the same if I were to ask you to find them. Still your second trace, your min and your max, same stuff. All right, I'm just going to hit zoom 6. Okay, so again, not very exciting stuff. Honestly, I care more about can you actually find me the max and min if I asked you for them, not just give me how many there could be. But that's just one little nugget of information for you. All right, sketch the family of polynomials using your graphing calculator. How does changing the value C affect the graph? So this looks crazy. We're going to do them all in one shot. So you're going to have, I'm just going to rewrite them y equals, and your y1. First, you're going to put 0 in for C. Now, let's get real. If I'm punching this in my calculator, are you really going to put in the 0x squared? No, 0. Okay, I would just put the x cubed. Then we're going to replace y2. We're going to have x cubed. We're putting 1 in for c. And again, we're just going to type these all in our y equals menu, see what we can see happening on the graph. Then they want you to put in 2 for c. And last but not least, they want you to put in 3. Okay, so I'm going to pull up my calculator. We're going to punch all of those in. We're going to take a look at them. Now, you can type them all 4 in the same time, that's fine. I'm going to kind of do it one at a time here just so we don't get ourselves too carried away. So let's just look at our parent function x cubed. We've seen the graph of this guy before. There it is, that's nice, okay. Then I'm going to put in the second one. Let's turn this one on to x cubed. I'm not going to type the 1, I'm just going to say minus x squared. Now let's compare these guys. I mean, looks pretty close to each other. I'm looking at the red, clearly it's kind of a little bit more. Let's put in the third one, x cubed minus 2x squared. Let's take a look with the third one in there. Let's put the fourth one in and see if we can come up with kind of a generalization here of what's going on. X cubed minus 3x squared. Oh man. X cubed. Oh, I hate this. Like minus 3x squared. There we go. So there. Look at the pink one. Okay, so. Blah, blah, blah. How does changing the value of c affect the graph? So clearly our c is getting bigger, 0, 1, 2, 3. The pink one, mine's in pink, is the biggest value of c. That pink one. So I would just kind of say, I'm not going to get too carried away here. To me, I look at this, and this is going to come into play when we start graphing trig functions. Yes, sine and cosine. We talk about hills and valleys. So to me, I look at this and I'm like, oh, that's got a bigger valley, that pink one on, a deeper valley, because you have more of a loop to it. So I'm not going to, well, here's my graph there. Put the graph on for you. Okay, I'm going to say that we have, as c gets larger, we have a bigger valley. So it's a bigger valley. I don't expect like perfect sketches of the graphs, but just enough so you can kind of see it, so you don't have to get carried away. All right, any questions on that? So, not a lot of new stuff, not new stuff today. So remember I said I got something super fun for you. Are you ready for it? You don't even know what it is. Jeez.